Welcome to Boston. My name is Max Versace. I am the CEO of Neurala, a Boston-based artificial intelligence company located just steps from here in the Boston Seaport District. 10 years ago, all this area was a bunch of parking lots, inexpensive parking for commuter rails, and the only building was the courthouse right behind me. Many things can change in 10 years. Take a look.
So as you have seen, in 10 years, a lot has changed in the Boston Seaport District. Unfortunately, the same cannot be said about industrial manufacturing. Not much has changed in that environment. We thought that 10 years ago, 2022 was going to be the year of lights out manufacturing, Industry 4.0, robotics, automation, AI implemented at scale to enable manufacturing to run without people. Reality is very far from that. It is true that the sale of robots has increased, it has tripled in the past 10 years. In 2018 alone, 420,000 robots were shipped, but the majority of those robots ended up in the traditional use cases of automotive and chip manufacturing. So not much has percolated into other areas. The first implementation of robotics happened in the 60s, and the same happened for artificial intelligence. So the beginning was synchronous, if you will, but while robotics has evolved in the production lines, AI has not. And one would wonder why. What is the holdup for artificial intelligence to fulfill their promises? A recent study by Capgemini has shown that only 1 out of 3 companies has implemented an AI initiative, within their companies. So what's the holdup? If we look at AI in manufacturing, there are in particular 3 main issues that it's facing today to prevent this technology to achieve scale. The first one is data. In order to train deep learning models, which is the branch of AI that has found the more widespread application in the world, you need a so-called balanced data set. This basically means that you need to collect, in case, for instance, of a quality inspection, visual inspection application, you need to collect a certain number of good data, so good products, but also data about defective products and the different kind of defects that your product might have. And that's where the problem arises. If you take, for instance, an IMA machine, those machines are so good that they produce very little defective products, which eliminates or hinders the ability to deploy AI models because you don't have the right data to train them. So that's an issue. The second issue is availability of AI talent. AI PhDs are scarce. In 2018, there were about 22,000 AI PhDs in the world. And if you take just the manufacturing companies in US, there are about 300,000 of them just in the US. And so you can see that there is already a gap between the demand of AI talent, which is very large, and the availability of an AI PhD, which takes 4 years to train. So that's the second issue. And the third issue is a compounding issue. So it takes the prior 2 plus adds some more. So the cost of building, maintaining an AI model depends on the cost of data collection, depends on the cost of hiring AI personnel, but also depends on other things such as hardware and the cost associated with finding, deploying, maintaining that hardware. And so very often, even if you have the data, even if you have the talent, the ROI or the return on investment of spending a certain amount of money in AI application is not justified by the savings that the company might realize. So all of these 3 issues play a very important role in creating a blockage for AI to spread from the labs to the real world applications. So in order for this to happen, you have to overcome these technical challenges, but also you need urgency from the parts of manufacturers. And in the pandemic, with all the negatives that has brought us, some positive have arisen for the industrial manufacturers. So this company have found themselves in a bind. Disruption of workforce availability in the supply chain, social distancing, fluctuation in the demand from consumer now working from home. So different things were needed. So all of these elements have conspired to give manufacturers of all sorts the right motivation to inject more automation, more AI, and more robotics into their premises. So now the motivation is there, the urgency is there, from all over the manufacturing world and the logistics, etc. And the technology now has to step up and solve those issues, the data issue, the talent, and the cost. So fortunately, the technology has moved forward, and I can give you some example. In the data issue, for instance, Neurala has been working with a very large Japanese pharma company to field their AI application in order to enable the analysis of chemical compounds and look for outlier, for instance, in very complex chemicals that are screened daily from researchers in this Japanese company. So in this case, as opposed to collect a balanced data set of good data and bad data, in particular bad particulates in the fluid dynamics compounds, the company was able to just upload a few good samples of good compounds and then be alerted whenever a deviation occurred in their data set. And so they can focus on the outliers and essentially eliminate the need of collecting a lot of data with defective compounds. So that's the data challenge which has been solved. The second one is the AI talent. And take, for instance, the work that Neurala has done with the UK frozen food manufacturer Appetito. In this case, Neurala was able to field a visual quality inspection AI application without the need of any AI-trained personnel, and able to, in 20 minutes, upload a few images of good frozen food trays and then be able to achieve 100% visual inspection in their production line so they could maintain the quality standard that they are known for. So that's the second challenge, this challenge related to AI expertise. The third challenge relates to the cost. And in this case, for instance, a very important aspect is the hardware that you need to train and maintain these AI models in the production line. And so Neurala has been able to field this technology, for instance, on CPU in a use case in an automotive environment where the company was designing parts to be kitted and then selected for mounting in a vehicle, implemented the technology just on a single CPU without having to wait for the availability of the GPU or having to pay premium for the hardware, which is really hard to obtain. Now GPUs are sought for not only for AI, but also for cryptocurrencies, for instance. So they are really expensive and hard to find. So now all of these elements can be solved. AI technology has stepped up to enable implementation where data collection is really easy, where no AI expertise is needed, and where the cost really justifies the end goal of implementing AI at scale. Today, in 2022, companies like Amazon, Microsoft, and Google are building cloud-based AI platforms that enable anybody, even without any AI expertise, to start to create and deploy AI models. Neurala is doing the same for the industrial manufacturing very unique use case, where we enable people on the production floor without any expertise in artificial intelligence, with only limited amount of good data and only an edge device without cloud connectivity to build, maintain these AI models for quality inspection directly on the production.
In 10 years, many things can change. In 2032, AI will make manufacturing unrecognizable. It might even be flawless.